Hello and welcome back. We are still in day one of this Mule advanced playlist. In this video, I'm going to make you understand about streams, how actually Mule supports streaming, what are variable Mule for streaming options, and when to use and how to use repeatable streams and non-repeatable streams. So let us get started. Actually, streams concept was introduced by Java in Java 8 or JDK 8. Before that, we were using collections. So, first of all, let us see one use case, what we used to do in earlier days, and how the same use case can be implemented using streams to improve the performance. So, right now I'm talking about Java, a Java application, but people who are from non-Java background try to get the concept. Okay, so normally we were writing web applications earlier in Java, and every web application will have logical layers. So we call data access layer will contain the logic which can access the data from a database. Service layer which contains the logic to implement business logic, and presentation layer where it contains the logic to render the views. Okay, let's assume this is a web application, and from a browser a request came to my web application. Of course it will come to the presentation layer, and we have to retrieve list of products in database. So how we used to implement before JDK 8 is the request comes to presentation layer. Presentation layer used to invoke service layer. Service layer used to invoke data access layer. Now the data access layer will fire a query, select star from products, and it will prepare a list of products, let's assume. And let's assume that there are some millions of products. Okay. Now the list size will be millions. I may get out of memory error in my application if my data access layer is returning a list of products. Of course, to improve the performance, normally we implement paging, etc. But let's assume that we didn't implement paging. We got a list of, let's say, 10,000 products. That too is too high, is it? Then we do some business logic and then render the data in the presentation logic. So for some amount of time, we need memory for storing 10,000 records. Suppose if 100 requests are coming for my application, for each request, my application may retrieve say 10,000. So 10,000 into 100, that means we require this much of memory for storing 10,000 into 100 objects. So my application may still go out of memory. So in JDK 8, they introduced a concept of stream. So now what I can do is, if I'm using streams, my data access layer, instead of returning a list, what it can do is it can return a stream object. Okay, and in the presentation layer, what we can do is we can do our business logic, and then to presentation layer also we can return a stream. So in presentation layer, we iterate over the stream and write data to the client or the user. So basically here, how does the stream improve the performance? Streams are not containers. Like list is a container of objects, right? We can store n number of objects inside a list or a collection. So streams are not containers. So actually what happens in the presentation layer, whenever my code tries to read the stream, this will try to actually retrieve the data from the stream returned from service layer, and this stream will try to read one record from the database. So if you know on database, whenever we fire a select query, our application gets a cursor to the result set, is it? So the stream returned by the data access layer will be internally having a cursor. That's all. An object is created. The cursor is not read. Okay. So this stream will contain the reference of the cursor. And this stream is returning another stream, right? Okay. So now in presentation layer, whenever our code tries to read an element from the stream, this stream in the presentation layer, stream object in the presentation layer tries to read an element from this stream. And this stream in the service layer will try to retrieve one record from the database using the cursor and return it. So basically what we are trying to do is we are retrieving the data on demand. Whenever we want to process, we are retrieving the data and processing. So we retrieve one record from the database, apply some business logic, and then return the stream, return another stream, right? So like that, the stream is lazy. Basically, we can read the stream on demand. Actually, the stream object is not containing all the records. Whenever we try to read an element from this stream, it will request from another stream, and this stream will go and read the records. So like that, streams are not containers. They can be used to read the data on demand. So let us try to put the same scenario in another way. Let's assume that we are developing some reusable components. This is component A, and this is component B, and this is component C. We are trying to build reusable components. Let's assume that this component A is trying to read from a database. Okay. And what A has to return the data to B. Let's assume that B has some filtering logic. Let's assume that B is a filter. B is having some filtering logic. And after it filters the data, B will give the result to C, and C will do some transformation, let's assume. Okay. And then after C does a transformation, let's assume that I have another component which will write to database. Okay. Let's assume that we have series of such components. Now, if we are not using streams, what this A will do? It will fire a query on database and it will return the list. And the whole list object is in memory. Then B will iterate over the list, do filtering, and return the filtered list. C will again iterate over the list, transform it, and then give the transformed list to this component, which is writing to database, right? So here A is returning one list, B is returning another filtered list, C is returning a transformed list. So just observe how much memory is required for executing this, right? But if we try to implement it using streams, right? The component A, if it can be written in such a way that instead of returning list, if this component A returns a stream object. So filter this B, the filter application, filter component, will operate on the stream on demand and return another stream object. C will again do the transformations and then return another stream object. So basically every component, if I can program it to return streams. So what will happen? This component A will fire a query on database. It will get a cursor to the result set, right? So A will iterate over the cursor. For each record from the cursor, it will write that record to a stream object, okay, which B will read. B will read the record from the list and apply the filtering logic and emit that element into this stream. The one filtered object is emitted to the stream. Now the transformer will apply transformation logic on that element from the stream and return another stream. Right? Here this database component will have some logic to read an element from the stream and write it to database. Of course, we can actually use this, we can configure this database component which is writing to aggregate up to say 50 elements, and once it gets 50 elements from the stream, we can write it as a bulk insert. That don't worry about it, right? So now in this case what happens, component A is never reading the whole data into memory. It will read one record, emit that record into stream. B will read that record from this stream and then emit to another stream. C will read from the stream, emit. So like that, if we are using streaming, we can actually utilize less memory. So we can we can actually process huge bulk records also, right? Or let's assume that this is not a database. Let's say component A is reading from a file. It's a file reader. So file, let's assume that it is CSV file. So this component A, what it can do? It can read one line from the CSV and then emit that line into the stream. B will apply the filter on that line, which is nothing but a record, and then write it to another stream. So like that, all the lines in the file will never be read into memory at once. Each record is read and it passes over and it will be finally written to database. So like that, using streams help us to actually reduce the memory footprint of our application. So hope you got a very good understanding about how streams work. Actually in Mule 3, there were no streaming options. So what used to happen? Let us take one scenario. Let's assume that I have a flow where this flow is polling for new files in a directory, and we are assuming that in a directory there will be CSV files of 1 GB size minimum, right? Or even more. Now whenever this component polls, let's assume that it finds a 1 GB CSV file. Normally what will happen is a Mule message payload will be a file input stream object, because we know that Mule is internally using Java, and to read files we use a file input stream. Normally the payload will be a file input stream, and then the next component, what it can do is it can actually read this file input stream. Let's assume that this component is writing to a file. Okay, so this component will read this file input stream and write it. Okay, after this component, suppose if I have one more component which is trying to again write to another file, will it be possible? No, because the input stream can be read only once. This first component has already read it, so second component will not be able to read it. So the stream is empty by the time the control comes to this component, and maybe it will write an empty file. Okay, so this is the scenario in case of Mule 3. Or let me take another scenario in case of Mule 3. Again, let's assume that I have a flow. Now my requirement is I want to write two files concurrently. So what I do? So in this flow, I'll poll for the file. And then what I do is I use something like scatter gather, where we can configure multiple routes. Suppose if I want to write to 3 files after doing some transformations, right? So what will happen? There will be 3 routes. So in scatter gather, what will happen? It will actually execute these 3 routes using 3 separate threads. And all these routes, if they are trying to read the input stream, so what is the payload for this scatter gather? Input stream. So scatter gather, what it will do is, it will create a 3 copies of Mule message, okay? 3 copies of Mule message. It will start 3 threads and give 3 copies. But the payload is still pointing to one single stream only. So all the 3 Mule message copies will be pointing to same stream. So if one of the route reads the stream, the other routes will not be able to get the data, right? So this is a problem in Mule 3. In Mule 4, they came up with a concept of something called as repeatable streams. So there are 2 types of streams, repeatable and non-repeatable. Repeatable stream and non-repeatable stream. Okay. Non-repeatable behavior is same as the one in Mule 3, whatever I described till now. But in repeatable stream, again there are 2 types. In-memory repeatable stream and file store repeatable stream. These are the 2 types. So let us discuss what will happen in Mule 4 now. Okay. So let's assume that this is my flow. Here I have on new or update file which will poll. So once it polls, let's say there is a file of say 1 GB size, of more than that. Then what this component will do is actually it will create a file input stream for pointing to that file and wrap it inside one more object of type stream. So this is a stream used in reactive programming. Okay. So normally this file input stream is different. It is used to read file. But again there's one more abstraction, a stream in reactive programming or NIO stream, etc. Right? So this is another stream object wrapping the file input stream. It will be created, right? And this stream, if it is configured as a repeatable stream, this will happen. Okay. So if I have configured on new or update file to use repeatable stream, then a stream object wrapping this one will be created, right? So this stream object internally will be using a buffer, a variable, maybe a buffer. So suppose if I configure in-memory repeatable stream, what will happen? Whenever the next component tries to read the stream, okay, first what the stream will do, it will use file input stream to read to the buffer, and from buffer it will return. Okay. But now when we are configuring repeatable stream, we have to tell what is the initial size of the buffer. Initial size, let's say I'll give 500 KB. So until it reads 500 KB from the file input stream, it will be in memory. Okay. Then after it reaches 500 KB, I can also configure increment. Let's say I gave increment as 100. So again the buffer size will be increased up to 600 now, 500 to 600. And then it will start buffering in memory. And what is the max size also we have to configure. Max is, let's say, 1000 KB. Okay. So until the file size is 1000 KB is read, it will be in memory. But what if the file size is more than 1000 KB? This will fail. because the maximum limit of the buffer I configured is 1000 KB. This will fail. So if you know that you are reading small files and you want the files to be repeatedly read, then you can configure in-memory repeatable stream, and you have to configure the max memory, what you are expecting the file maximum size to be. But if you are reading big files, maybe in GBs, in-memory repeatable stream will not be your option. Then you have to configure file store repeatable stream. In that, you just have to configure what is the size of the buffer. So let's say I configured the buffer size is 500 KB. Okay. Now what will happen when this next component is reading the stream? First, it will use a file input stream to populate the buffer and then give the data. But after reading 500 KB, whatever has been allocated, then what will happen is it will write to the temporary file in your disk also. Right? Whatever is read from the file input stream will be written into temporary files. So that is why it is named as file store repeatable stream. Right? Now suppose if the next component is also writing to file, this is also writing to file as I showed you earlier, this is also writing to another file. So what happens is this will get one stream object, this component will get one stream object, it will read the stream. While this component is reading the stream, what happened? The file is actually read by using file input stream, and all the file content is now populated to temporary directory and also buffer, right? Then when the next component tries to read from the same stream object, right? Whenever it tries to read from a stream object, it will again start reading from the first. So that's why it is called as repeatable stream. So we can read it n number of times. Like now if you take this scenario of scatter gather also, right? All of the streams, actually what the scatter gather will do? Scatter gather will create a copy of the mule message. But all the copies will be having a reference to same stream, a repeatable stream, right? So they can read the stream n number of times they want. So that is the concept. Okay. Okay. So now you understood how repeatable stream works and different types of repeatable stream. And one important thing when you're designing your applications, suppose if you don't have a requirement to read the same stream again, you're just reading the stream once and you're just doing some computation and all. So do you really need repeatable stream? Is it not a overhead? Even if it is in memory also, it's storing in memory, right? So when you know that your use case is not going to read the same stream more than once, make sure that you configure non-repeatable stream. So you have to carefully choose what type of stream you want. Okay. So that's the theory. Now let me show you practically here with an example. So what I am doing is here I have on new or updated file here, and if I select it in advanced, on this one in advanced there is streaming strategy. You can configure non-repeatable stream or repeatable in-memory stream or a repeatable file store stream, right? Suppose if you configure a repeatable file store stream, you have to specify what is a buffer in terms of some unit, either KBs or GBs or MBs or bytes, right? By default it is 512, right? Or if you are selecting in-memory stream, see here, you have to specify in some buffer unit, what is the initial buffer size, buffer increment and max? By default it is 256, 256, 256. Maybe what you can do is you can make it as 1024 as a max, and initial buffer size is 256 and buffer will increment by 256 every time. So you have to configure the streaming strategy based on your use case, right? So now let me make this as non-repeatable stream. Okay. Now I have kept a breakpoint. So here after reading I'm calling this flow where I have a logger, and here I'm just writing the payload. Now I configured the streaming strategy as what? Non-repeatable stream. So let us see what will be the payload here in the logger if I debug it. I've kept a breakpoint, and then let me debug it now. I'll pause the video. Yep, the application got deployed and now I'm in debug mode. Now this files on your update file is polling for files in this directory. So let me keep a file. I have a CSV file, sales.csv. I'll keep it into this input folder. And now let's go to Studio. Yes. Here what you can see is the payload is an object of type file input stream, using which we can read the file, right? So as I clearly told you, this is non-repeatable stream. So what will be the payload right now? File input stream. File input stream. It is not a repeatable stream. If I have configured it as a repeatable stream, this file input stream will be wrapped inside another stream object, right? So that is not happening. So I got file input stream. Now, if this is a file input stream and if it is going to scatter gather, let us see what will happen. I'll press F8. See, even in the logger itself, I'm getting an error and all, right? So it will not be able to actually read that input stream right now. Okay. Now, let me change it to repeatable stream, either in memory or file store. So let me make it as file store repeatable stream. The memory is 512 KB. I'll make it as bytes. Okay. So you have to choose what should be your appropriate buffer size. Okay. Then here if you see what is happening, I'm using scatter gather to write two files, right? So if you see here, what is this pointing to? It is pointing to file1.txt. It will write a content to file1.txt, and this one will write to, second one will write to file2.txt. So I'll do one thing. I'll go to C:5, this is my root, and I'm going to delete these two. Okay. So there are no such files like file1.txt and file2.txt. Now I'm using scatter gather to write concurrently, right? So I'll delete this logger as well right now. Now did I configure this to file store stream? Yes. Now let me restart. Here in the input I have to put the file. Oh, it's already there. Let us see now whether it will be picked up, processed or not. So it's still starting up. I'll pause the video. Okay, yes, so the application got started. Let's wait until the file is picked up. Yep, I think the file is picked up and the logger also is has written the data. Now let me see here, are the two files created, file1 and file2? Yes, same size as sales.csv, right? So by using scatter gather, I was able to concurrently write. So I made use of repeatable stream. If I change it to non-repeatable stream, the scatter gather could have thrown an error, right? Okay. So now you understood about how to configure each of this. Now let us talk about the streaming in case of database. So here also, if you see in database, let's assume that in database I am firing a query which will return in millions of records. So here I am writing a simple query, select star from product, but assume that my query may give a lot of records. So I need to configure some strategies. I don't want all the records to be read into memory. I want streaming here also, right? Again, here also if I go to advanced, here also there are strategies, but here you have to recognize it is iterable. They're ending with iterable because database components will actually return an object of iterable. So non-repeatable iterable, repeatable in memory, repeatable file store, but they are not streams, they are iterables, right? And here you can configure how many in-memory objects. Let's say by default actually it is 500, right? So what will happen is, again here also this is internally using file store iterable, right? So here you need to understand in the flow, here is my database component. What it does is it is firing a query and it will get a result set. Actually it is internally using Java. It will get a result set object which is like an iterable. This result set is wrapped inside an object called as iterable, which is similar to stream only. Iterable stream we say. And this iterable object will be the payload. Now this in iterable also will be having a in-memory buffer, and we have to specify the buffer size not in terms of KBs, in terms of how many objects. Basically result set will read objects, right? So you have to configure here the buffer size in terms of objects, 500 objects. And also this iterable is can be backed by a file store if it is a file store repeatable iterable, right? Concepts are same. In case of file streams, I was specifying the buffer in terms of KBs, but here the buffer is as number of objects, in memory objects, right? That is the difference. Concepts are same, only whether it is an iterable object, whether we are reading objects or whether we are reading a stream. That's about streams. Even in case of HTTP also, if you see, I'll show you one example here. Here I have a flow which is taking HTTP. Let's assume that I'm getting a HTTP post request and somebody is posting 1 GB data. So in this HTTP listener also, if I go to advanced, here also I have streams configured, same as like file, repeatable or non-repeatable or a repeatable file store. So based on your expected payload size, you have to configure the corresponding stream. This will make a lot of impact on performance. As an architect, you need to take an appropriate decision and configure exact streaming strategy what your application requires, right? So by default, if I configure this as non-repeatable stream, can you guess what will be the payload to scatter gather? It will be a HTTP stream object. There also HTTP stream object. But if I configure the stream to be a repeatable stream, whether it is file store or in memory, then what happens? This is HTTP. What happens? HTTP input stream, some input stream object will be wrapped inside one more stream. Okay, so this provides me a way to repeatedly read. Again, it can be buffered or it can be backed by a file store. Concepts are same. So now we understood about streaming strategies. So there are a lot of components in Mule 4 which supports streaming strategies. Even Salesforce components, if you work with Salesforce components, also can be configured with a streaming strategy, just like a database. So that's about streaming. In later lectures, I'll show you a use case where you have to decide what is an appropriate streaming strategy for the scenario. Okay, I'm preparing you for with the basics so that you can take decisions based on our knowledge right now. Okay, what you can do is now you can go to my GitHub repository. The link of GitHub is given in the description of this video. Go to day1 folder of the Git repository, open the document related to streaming, step by step follow the instructions and complete the exercise. Don't go to the next day video until you do this exercise. Practice is very important. Seeing the output on your machine makes a lot of difference. See you in next lecture.